Alrighty, so now we're going to be looking at solving equations, and we're going to use concrete materials such as algebra tiles along with our mat to learn the logical processes of finding the value of a variable in a linear equation. Okay, and we're going to use our properties of equality as well. So solving one-step equation here. Okay, so what are we talking about? Solving something like x plus 4 equals 7, and then maybe like 7x equals 15, something like that. Okay, so how do we do this in general? So most of us probably remember how to work through this. If we have the equation x plus 4 equals 7, most of us should know, well, what plus 4 is 7? That's just going to be 3. So we can kind of figure that out. How would we demonstrate this with tiles, though? So what we do is we first go ahead and you can either draw it out, or if you want, we also have, you can use your tiles over here. We have tiles. And then, so you have the following here. So you have two methods of doing this. So notice our goal right now, and notice I've represented this as the following. This is x plus 4, and then I have 7 here, equals 7. So what you can do is the following. You can either subtract these 4, and then take out 4 here, okay? And if you notice, what you're left with here, this is how you know that you're done. You have a single x tile. Remember, this is your x tile here. This is x, and it's going to be represented by a blank one here. And then so that is equal to what? It's equal to 3. So then when you're done, you say therefore. So we took those out, okay? So that's essentially what was done here. So you have, what they did is they crossed off 1, 2, 3, 4, 1, 2, 3, 4 here, and then they got what? They got x equals 3, so x is 3 here. That's one way we can do the problem. Another way we can do the problem is simply by adding the opposite, okay? So in the same sense over here, we have, if you remember the problem, it was x plus 4 was equal to 7. So just get this set up over here. So what did they do in this case, or what was done? Essentially, you want to add the opposite. That is to say, you add the opposite number of tiles so that you can isolate this guy over here, right? This solid one, okay? So what does that mean? So that means when you're having this out, okay, with your tiles, you set up the equation, and then you say, well, I want to cancel. Remember, this is a 0 pair. Each of these are 0 pairs, right? And then so you go ahead and put your 4 over here. 4 tiles, 4 tiles. These go to 0 now. These go to 0 because you have their opposites, right? They're 0 pairs. And again, you're left with x equals 3 again. So it's essentially what happened here. So I think in general, this is the general methodology. So this is the one that is used. These are 0 pairs, so these all go away. Remember, these are 0 pairs. Okay? Okay? And so you get x equals 3 here. Okay? And this is another way of doing it. Okay? What happens if you have negative x plus negative 4 equals 3? So in this case here, what you want to do is, remember, we can easily solve this over here for negative x. So what am I saying here? So notice, if we draw it out tile-wise, so we have negative x, and we have minus 4 here, equals 1, 2, 3 here. So what happens? So I can solve this, and I can add the opposite, right? So I'm adding 3 of these to both sides, because this gives me a 0 pair, and they're gone. So I'm, well, actually, I should add another one over here, right? To cancel all of them, sorry. So then what do I get? So I have this one here equals what? That's 7, right? It's 4, and then that's 7. That's 7 there. Okay, but the problem is, this is not x, this is negative x equals 7. And that's not what we want. We want positive x. So even before we do anything, what you should do, if you're confronted with something like this, is you want to do the following, right? So you take your tile right now, okay? And we're going to set this up really quickly. And I'm only going to demonstrate this a few times. And then we'll draw it out, okay, thereafter. So you have your setup here. Here's my little setup. So what do I do? So the first thing you need to do is you need to actually move this to the other side here. And so how do I do that? Well, we want to add the opposite. So what's the opposite of this? It's going to be a positive x here. So we're going to add that to both sides of the equal sign, right? And then these cancel to give me 0. And what am I left with now? Now I have x plus 3 equals -4. And now we know how to solve this one. Because now I notice I have positive x, which is what I want, right? And this is essentially what has happened here. Essentially, we've added a positive x to this side over here. These cancel to 0, and I'm left with just this one. Now, once I have x here, what do I do? Well, I can just add the opposite. So it means here I'm going to put in 3 negatives, right? And then I put in 3 negatives here. Now, the big thing is, now if you notice, these are not opposites. They're not 0 pairs. They're all negative. So that means these cancel, and I'm left with x equals -7. So x is -7, which is what we have down there. Okay? Okay. So, and you want to read the instructions carefully. You want to use algebra tiles, okay? And we're going to solve this one for x, and then we're going to state the property we used here. So notice, so what you do in this case here. So I'm only going to do a few of these, and then you should really practice the rest here. So for a, so if I have 3, and then x here equals -6. These are all shaded here. Okay, so what do? I add in 3 negatives, shaded. Let me add in 3 other negatives here, shaded. So these are 0, 0, 0. And now I have, this is x equals what? I have, it looks like 3 by 3, right? And they're all shaded. So that's going to be x is -9. Okay, and what did I do? So here's my sketch with my tiles. So x was -9. And then what property did I use? So I subtracted, so this is the subtraction. Prop of, you can just put equality for an equal sign there. Similarly here, for b, so this was a here, okay? What about b? What do we get? So I have x, and then I have the -3, so that's negatives. There's 3 little negatives, right? There's 3 of them. And then equals what? 3 positives. So I want to isolate this, so I'm going to add 0 pairs. These are 0, 0, 0. So I have x equals, was it 6? So then x is 6. And what did I do? I added 3. So it's going to be the addition property of equality. Okay. So the last one that we'll do is we'll go ahead and do C here. Let's just go ahead and do C really quickly. So what do I do first? So C, I have negative, and then I have four tiles here. You get good at drawing these after a while, right? So we have 4 little negatives, and these are all negative here. And then what my goal is to, first, I need to add this over. So then I'm going to add a solid here. So these cancel to 0, and now I'm left with 4 blanks is -4, and I have a solid. Now I want to solve for this one, so I'm going to add in my 0 pair here. So that's 0, 0, 0, 0. I'm going to add in 4 more here, because whatever I do to one side, I have to do to the other. So then this gives me here that this one is going to be 8. So x is 8. Okay? So then x is 8. And I used a couple properties, but technically I'm just adding. So this is just the addition property again. Is the addition property of equality. Okay. Similarly here, so you want to go ahead and finish these off. You can check your work really quickly. So if we do this one here, x was 7 here, this is 9, and this is 7. Here, this is going to be negative 8. This one is 8. This one here is going to be 11. This is 0. This over here is 9. Excuse me, negative 9 here. And then this one is negative 2. Okay? And then you want to make sure you go ahead and draw them out for these. Okay? Okay. So this is one actually where you will need to kind of pay a little bit more attention when you're using the division property of equality to solve these problems over here. So if you notice, like, what do you do if you have to divide tiles? Because that's a little bit weird. So notice you have 2x equals negative 6. So what do you do if you have such a situation? Well, so like if I have, so it's 2x here. And there's 6 negatives, right? Let's just draw that, make that out really quick. Okay. Okay, so here's 2x and here's 6 negatives. So what do? You basically want to literally divide it out. So because your goal is to solve for this tile here, right? So what you want to do is you want to break up each tile so that they have an equal number of pieces to each tile, right? So in other words, notice here, this has 2, this has 4. That's not equal here. Right? The same thing if I did this here. This has 1, that has 5. But if you notice, if I can balance them out here, now I know what x is. What is x? X is negative 3. Okay? And that's how you divide with tiles. This is exactly what is shown here. So you break them up, and then you draw them out. You separate them out so that each x has an equal number of numbered tiles, and you can conclude your answer here. Okay? So we're going to draw these out over here. So this one here would be what? So I have 3x. You don't have to draw them sideways, but it's nice. So you have 3x, and you want to draw them out, and it equals 12. So let's see. So you want to break up 12 into what? Into 3 equal pieces, right? And so how do I do that? Well, that works if each of them have how many? 4. Okay, so then you can say x is 4 here. Similarly here, you'd have 4x equals 8. So that means you need 8, 2, 2, 2. See how they're all equal here? So x is 2. Same thing here, 12x equals 12. So you'd have 12, so each one, there's a lot of them here. It's 12. Cheat. Is that 12? Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's pretty good. And they're all over there. Okay. And we get the idea. X is 1. Okay. Same thing here. So notice, so you have 6 x's. Okay. Here's my 6 x's here. And we want them to equal what? Negative 6. 1, 2, 3, 4, 5, 6. You just kind of fill them in as you need. X is negative 1. Okay. So notice, so this is just going through another example. Notice this is negative 3x equals 12. The same thing. You set them equal, and then you separate out the tiles so that each x over here, so that each one has the same amount. The only problem here is if you notice, this is not x, so this is negative x. So what this gives me is negative x is 4, right? However, if we were to rearrange these, so what you want to do then is you can simply add x and then subtract 4 to both sides. And what you'll get, which is shown here, by the way. So if you add x, that cancels, and these cancel, and you're left with x equals 4. Oh, excuse me, negative 4 here. Of course, this is also done just by dividing by negative. If you have negative x equals 4, you can divide by negative 1, and then negative over negative is a positive. Positive over negative is a negative here. It's negative 4. Okay? Okay. So for these, you want to use tiles and to find the answer, then draw them out. So if you notice, I'm just going to do one of these and you can do the rest. So I'm going to have 5x here. 5x, negative, sorry, they're all negative. Equals 15. So then you want to break up that into 15 into 5 equal chunks. So that's going to be what? I think that's 3 each, right? Is that right? Let's check. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we can conclude negative x is 3. So therefore, x is negative 3. Okay? We can just divide by negative 1. It gives me that one. Okay? The same thing goes over here for b. You should get x is 2. Okay? All right. Now, what's another way of doing this? And many of you have seen this before as well. So, alternatively, what can we do? If we have 5x, negative 5x equals 15, we could also just divide by what is next to it, i.e., because the operator here is multiplication, the opposite is division. So I can divide it by negative 5 here, and I get x is 5 over negative 15, which is negative 3, which is a little bit faster. Same thing here. If you have negative 4x equals negative 8, you can divide by what is next to x, which is negative 4. Negative 4 divided by negative 4 is 1, so you get 1x equals 2. Why 2? Because negative 8 divided by negative 4 is 2, right? Or x equals 2. Of course, the same thing. Which is what is shown over here, so you should go ahead and do A and B. Go ahead and pause the video and do those quickly. Okay, I'm going to do them now. So you should have divided by negative 4, so x is 4. Similarly here, divide by negative 7, so x is negative 5. Okay? All right. So what do you do when you have some kind of rational number, i.e. some kind of fraction or decimal? It's the same exact thing. Okay, you do the same exact thing. So if you notice over here, if you have x plus 3.25 equals 5.5, you want to simply add the opposite. So for example, if you have x plus 3.25 equals 5.5, you want to subtract 3.25. You want to do the opposite, minus 3.25 here. These cancel. And x is, you have to subtract these now, right? So 5 minus that. 0 we have to borrow, so it's going to be 4. 10 minus 5 is 5. 4 minus 2 is 2. The decimal comes down. 5 minus 3 is 2. So x is 2.25. Okay. Same thing over here. If you have for x equals 7, you want to divide by 4, right? And then we get x is 7/4. Notice these cancel to 1. There's a 1 here. Alternatively, by the way, you can also multiply by the reciprocal. So that is to say, if you have 4x equals 7, the reciprocal of 4 is 1/4. Multiply by 1/4. These cancel to 1 again, and you get x is 7/4 again. Okay. Sometimes this way is more helpful. That is the second method here. So, method 1. So if you want to know what happened over here, so this is done over here. That's method 1. Okay. And you want to go ahead and practice these over here. Take a second. Okay, pause the video, do them out. So we should get here, I divide by 9. So x is 12/9, but we must reduce or the answer is incorrect. So we get 4/3. Okay. You can leave it improper. Here, now this one might be a little tricky for you, but we're going to use the method over there that we used. So we're going to multiply by the reciprocal here. The reciprocal of this one is going to be 2 over negative 7. Do the same thing to this side, 2 over negative 7. And then these cancel to 1, so I get x equals, and now we have to simplify this. Here, notice, so that I have 42 times 2 over 3 times negative 7. 42 goes into 7 6 times, 7 goes into 7 1 time, so x is 6 times 2 over 3 times negative 1. Remember, there's a negative here, and that's going to be what? Well, that's 12 over negative 3, which of course is just negative 4. Okay. Over here for C, so we want to first subtract 5 and 1/3 over, minus 5 and 1/3 over here. So that gives me then negative x equals 13 and 1/2, negative of course, minus 5 and 1/3. I'm going to change these to an improper fraction. So this is going to give me negative 27 halves minus 16 thirds. Let's get a common denominator, which is 6. Okay, so then this needs 3 over 3. This needs 2 over 2. 3 times 27 is going to be 81. So that's negative 81 sixths minus, over here, this is going to be 32 sixths. Okay, and because they're both negative, we're going to combine them. And then we have negative x here on the other side here. Remember, this is a negative x follows down. So what does this give me? So I have 81 plus 32, which is going to be how much? Let's go ahead and add that up. So is it 3 and then 11? So 113, so negative 113 over 6. Now I divide by a negative, or if I want, I'm going to multiply by a negative because it's the same thing. And this gives me here that x, now it's x is 113 over 6. We can leave it as such. And the same thing here for D, I'm going to subtract 25 to both sides. And x is 0. There's nothing left. Okay. Okay. So we want to go ahead and do the same thing over here. Very quickly, let's just go. We can go ahead and go through the steps here. But you should practice these out and kind of work these through over here. Okay. So here you want to divide by 7.5, divide by 7.5. So we can get our value here. And then you would use your decimal division. So you would say 7.5 is being divided into 22.5. Move it over 1, move it over 1. So then we have 75 is actually going into 225 here. And now we have to think, how many times does 75 go into 225? What is that? 3 times, I believe. Let's double check. It's 20. Yep, so it's 3. Remember, it goes over here. And so the answer is 3. Okay. Same thing here. We're going to subtract 12.32 here minus 12.32 here, etc. And then you're going to get x is this difference here. And hopefully when you're doing these problems, by the way, you should be kind of going through this same process here. Okay. I'm going to leave the rest of these over here for you guys to do. Okay. The last thing we're going to do is two-step equations, and that's essentially over here when we have to do two operations. So notice here in our tiles, this is 2x minus 4 equals 12, so I have 2x's minus 4 is 12. The first thing we want to do is we want to isolate our x's, so I'm going to add the opposite. So here I'm going to add in some solid tiles here. These cancel to 0. And I add in those same 4 here. So notice that's exactly what was done here. So then we get 2 of these x's equals how many of that? Which is 4 more plus 12, so that's 16. So 2x equals 16. And we divide them up. 2 into 16 is 8. So x is going to be 8 here. You can see how they broke them up into 8 chunks. So you will have probably at least one question where you have to do this on the test and draw it out. Okay? So what am I saying here? So you need to start out with the following. If you have 2x, so you should draw it out, 2x minus 4 equals 12. I'm going to cheat, draw this out here. Okay, and then that's gone. Ignore that. So I have I have 2x minus 4 equals 12. And then we go ahead and solve this out. So I'm going to add 4 to both sides. And then I get 2x, sorry, these are 0, equals 16 now. So that's what? 4 by 4. So if you notice, this is a bad picture. I need to break these up into 2 set chunks, right? So then I need to say, sorry. So then I need to say that this, well, is going to be 8 over here. And this one is going to be 8 pieces over here. So therefore, x equals 8. Okay? And this is how you would draw it out. All right? If it said to draw it out, you need to do so. Okay.